Okay, I think we are live. It's time for Monday Night CAD, and today we're taking a break from the lure turner, and I'll explain what I have here in a minute. Basically, I'm doing a project to organize my lure painting and lure making supplies. So as you can see, my desk is very messy. um, So I made this stand, which is not my original design. It's done by someone called KYZ Design. You can find it on Printables or MakerWorld. And I have printed the stand, and the base of the stand has these holes, which are part of something called Gridfinity. I guess we can open it here in Printables or somewhere else. Let's put it here somewhere. So yeah, the base of the stand has these cutouts for what is called Gridfinity, which is a standard for organization stuff. You can find it everywhere. And what I'm thinking of doing, because I want to hang these small paint bottles, I want to hang them on the wall itself, on the stand. But I thought I can use the space here, for example, to hold these big, heavy bottles and maybe some other stuff also. Because I don't want to put these on the stand. I don't want to put too much weight on it because there's going to be lots of weight anyway because of the small bottles. So I don't, yeah. And also if I put these, they're going to take too much space. So maybe put them down here and then they're probably gonna reach this height and then start organizing the small paint bottles up here. At least that's the plan, which I thought should be super easy, but apparently cannot find any useful step file. Do you have a step file? No, they all have STLs. Now we can use Blender, I guess. We can import STLs into Blender and modify them. I don't even need that cutout here. These cutouts, these are for magnets. I'm not intending on using magnets. I think, let's see, grid affinity standard or something like that. Yeah. So we have the standard. We can probably we can model it. 0.8, 0.4. We can even make it stackable. I don't think I'm gonna make it stackable because there's gonna be paint bottles in it. So if I want to make it stackable, then this has to go all the way in. So no, not for this thing. Maybe we could make it like just one slot. Then we can print like 1, 2, 3, let's say, because I have only 3 bottles, and later if I bought a 4th one, then all I have to do is print 1 extra slot, because if I make it 3 or 4 slots, then I'm limiting myself. I think I'm gonna make it only 1. So technically, I can remix this part right here. I don't know why it's red on the inside. Which one is this? This is this one. Huh. It's 2 bodies. Interesting. Transparency 70. Transparency set it to 0. I don't know what's What is this for? Fill? Ah, wait. I think we can do a boolean on these to fill it up and then cut it out somehow. But before I do anything, I need to measure that bottle. Give me a second. So here's a Vallejo surface primer, for example. I'm gonna measure the diameter. And it's 40. Wait. Yeah, 49. It's a 50 mil. 49.2. That's a 50 mil. Let's go to part design and let's measure this right here. Yeah. It's small. Not gonna work as one. So we definitely need something like this, or even a 4. But let's see first. Parametric file. What do you mean by parametric file? Fusion 360. Let's see. Infinity free CAD. Huh. Okay. So someone created an actual workbench. Can we see it in action? It works with part design also, which is nice. Interesting. Okay, wow. I want this. Free CAD, okay. Let's see. So we don't need this project. I'm gonna close it, don't save. Create a new project. Tools, add-on manager, Gridfinity, wow, okay. That's convenient. I was not expecting to find anything, to be honest. When I did the Google search, I was like, yeah, let's just check. I think it's gonna restart. Yeah, restart now. Why did the music stop? What's going on? Okay. So we need to go to part design first, create a body. Maybe we should have created a part. Wait, so yeah, I'm creating parts now before creating bodies. That's a better approach. Gridfinity. Interesting. Blank bin. Simple storage. Echo bin. Parts bin. Simple base plate. Magnet base plate. Nice. So let's create a blank bin. I guess we need to toggle this as an active body. Go back to Gridfinity and create a blank bin. Wow. I love this. Okay, and I guess we can control. Let's see what we have control over. Magnet holes. Okay, let's say I don't want them. What else? Screw holes. I also don't want them. Stacking lip. I think they're talking about this, and I guess I can turn it off. Let's see. Okay, cool. So if I'm planning to stack them, then I guess I would use the magnet holes and the stacking lip. X units, we can increase that. Wow. Nice. 2, okay, cool. Custom height, magnet hole depth. Okay, cool. These are for experts only. Tolerance on each side of the bin between before. I'm gonna leave all of these as default. And let's go with the 2x2 for now. What I want to know is where's the origin? Huh. So I'm guessing the origin is in the center of the first one. So if we come here and set this to 1x1, yeah. The origin is in the center of the first section. Now, how wide is each section? I should probably have its total width 83. Grid size 42. So that means if I go back to 1x1, if I measure the distance, where's the measure? From here to here, it's 41, and from here to here, 41.5. And this is bin unit, 41.5. Size of the grid. Interesting. What is size of the grid? Let me look at it from the bottom. Maybe it's still here. Okay, I got it now. So the size of each one is 41.5, but there's a 1 mil, I'm guessing. Let's see. There's a 1 mil. Or a 0.5 mil between each two. .5, and the 0.5 mil in between. And here it's the same. 0.5 in between. Clear all. Anyways. Let's do something super simple. And then we'll see how it goes. So I want to see if I can access these. That will be amazing. And I guess we can do that. We need to first create a spreadsheet. And one thing I'm starting to do is move the spreadsheet into the part. So for example, let's rename this to paint holder, for example. And then here we can call this paint holder params. So if we have lots of parts, this is gonna be organized. Now the question is, if I say here, like for example, bin blank dot, okay, I can access X total width, Y total width. Let's see, bin unit is the 41.5, cool. And we have the total width. Okay, that's amazing. That is amazing. Let's put it here. Actually, let's rename this. Oh no, I think it's fine. Bin blank. Paint holder grid. So we can go somewhere and say paint holder grid dot X total width. Put it here just for reference. Paint holder grid dot Y total width. And let's change this just to see what's happening. So X is where, yeah, it's correct. X is a smaller value, Y is the bigger value. And you can see here the red line is X. So also the axes are correct, which is amazing. Amazing. I want it to be wider, I guess, so I'm gonna go with 3x2 for now. Okay, cool. Now let's see how we're gonna lay them down. First of all, let's go with bottle diameter. Let's do 50. We're gonna call this bottle diameter. Maybe spacing or not spacing. Do we want to fill it with bottles? Like for example, give a thickness that we want the minimum spacing to be 3, and then calculate the number of bottles that will fit while maintaining a spacing that's bigger than 3. Or we provide the number of bottles and then auto-calculate the distance. Like I want to fit 3 bottles and then calculate based on that. And then we can give, for example, a padding of 10. I want it, for example, to be 10 mil away from the edge. It starts from here. And then I want 3. I think that's going to be like the optimal. Yeah, I think I'm going to go with that way. So let's call this the number of bottles. And let's call this padding. Okay, so let's calculate some values. So if we have a bottle diameter of 50, we have 3 bottles and there's a padding of 10. So let's say this is the padding. This is the first bottle. And let's assume we have some space here. We want to calculate this amount. We have the same space here. And let's say this is the other padding. Okay, so we have, let's go here. We have a padding and a padding. This is our total width. So if we remove these 2 paddings, we get, sorry. This is another bottle and then this is the padding. Yeah. So if we remove this padding and this padding from the total width, we get the width of this entire thing. And then we need to remove 3 50s. So we need to remove these 3 and we get the length of these 2 and then we divide it by 3 minus 1, basically. So we're gonna call this spacing between bottles. And the spacing between bottles is gonna be equal to, let's do, you know what, let's give me this. I'm gonna call this here x total width, and this here y total width. So we reference external things once. And now I'm gonna say, yeah, so we're gonna get the total or x total width, remove 2 times the padding, and remove number of bottles times the bottle diameter. And then, oh, come on, what happened? What happened? Wait, x total width minus 2 times the padding minus number of bottles multiplied by bottle diameter. Okay. When did things go wrong? Recompute failed. Huh. Is it the x total width? What? Minus 2? Huh. That's interesting. What if I did this? Sorry, I have to hit enter. Okay. Because this is a millimeter. Okay, so in FreeCAD, if you just put 50 here, it's a number. It could be anything. But when you put 50 mil, it's no longer a number, it's a distance. Something like this, for example. So you cannot take a distance and just say -2, I think. Yeah, you have to say, yeah, -2 mil, which is crazy, but so this is x total width minus 2 times padding. This should work now. Yeah, because padding is now a distance and we're multiplying it by 2, which is also a distance, so that's fine. Minus number of bottles. Okay, number of bottles is not in millimeter, it's a number. And where is the music? Why is it not auto playing? I don't get it. Minus okay, number of bottles multiplied by bottle diameter. Cool. So now what we basically did is we removed the padding, we removed the bottles, and we ended up with this. So now we need to take all of this and divide it by number of bottles minus 1. Now we have a problem here. What if we put 1 bottle? If we put 1 bottle, then we're dividing by 0. Did it even work? What happened? Wait a minute. No. Why? Divided by 2. Okay, so that works. Number of bottles -1. Okay, now it works for some reason. That was weird. Anyways, this is going to be the space between the bottles, between each bottle. So now if we move by 10 mil and draw a circle and then create a pattern that is, let's say, 3 with a distance between each object of, that was negative. Interesting. Maybe they don't fit. Let's see. Probably they do not fit. So if we get a negative value, then there's something wrong, right? Because they will not fit. Now, if I put this to 1, we're gonna have a major issue. Yeah, it's gonna be infinity. Number of bottles -1. Is there a way to calculate this without having infinity? One bottle. It should be 0. How do we do that? It's divided by number of bottles -1. I remember I did that previously. Okay, I'm crashing. I'm sure there's a way. I did it. I for sure did it. But I think it was different. I was calculating like the total spacing. I was assuming that these are equal. Maybe we don't need the padding. So if we remove the padding and we're assuming these are equal, then all we have to do is remove these 3 and then divide by number of bottles +1, then we will never have infinity. Let's try this. So here there is no padding, and then we divide by m+1. So the padding is also the spacing, basically. So it will work for 1 bottle. It will also work for 2, 3, whatever. Let's try it. Are we sure? I mean, this will only fit 2 bottles. Let's see. So we need to create a sketch here somewhere. So to create a sketch, the XY plane is fine. We're gonna create it on the XY plane, but we need to know where is this and this. Let's see. So like this, go to part design. The body is already active. Let's create a sketch on the XY plane. And we want to know where this line is, right? And it was probably a good idea to create a datum plane, but give me a second. We will do that. Or we can move the body. Yeah, let's close the sketch. Before we do the sketch, let's click on the paint holder. Oh, we cannot move it. Interesting. That's not a regular body. So we need to create a datum plane. Now I'm just gonna work from here. So the distance from here to here is going to be, let's first create a circle somewhere. So if I take the horizontal distance and let's set it to paint holder grid dot grid unit, wait, bin unit divided by 2. Yeah. So that's gonna be the edge. Now we want this, not the center, but the edge to move away from here by spacing between bottles. So how do we do that? So now we're at the edge. Now we want to remove spacing between bottles, and now the center is in the position that we want, but we want this, so we need to remove the radius, which is the diameter divided by 2. Now we can take, no, it's fine, never mind. So now we have the X position. Let's use the, okay, interesting. I didn't think about the Y. I was only thinking about the X. Okay, let's close this for a moment and let's think about the Y. So I think we can do something here. Number of bottles X, for example, or let's say X number of bottles, and maybe Y number of bottles, and let's say here it's 3, for example. We're gonna rename this to X number of bottles, and this one is gonna be Y number of bottles. So we're gonna copy this, put it here, and instead of X, we're gonna use Y. Okay, cool. Divided by Y number of bottles. I think there's a typo. Which one is correct? It's like this, I think. No? No, both of them are red. Anyways, I'm not gonna deal with this typo now. This is embarrassing. Okay, we're gonna call this X spacing. And let's call this one Y spacing. Nothing is red anymore. Put this to 2. It does not fit 2. Wow. Now here's the beauty of this. It should, theoretically, when I set it to 1, put the bottle in the center. So let's see. So now we should do the exact same thing, but on the Y. So if I move this down, now here's one cool thing about FreeCAD. When you do a horizontal distance or a vertical distance constraint, it's signed. So if it's up here and then I constrain it, you're basically telling it that a positive value will push it up, a negative value will push it down. But if it's here, it's going to be the opposite. A positive value will push it down, a negative value will push it up. So if we do this now, what was it called? Wait, the grid. Bin unit divided by 2. It's gonna be here again. And now we need to remove the Y spacing. And we need to also remove the diameter divided by 2. And this will put it in the center. Exactly in the center, because we only have 1 on the y-axis. And now I can constrain the diameter to paint puddle params dot diameter. And now let's go here and let's do a cutout depth. And let's say this one is gonna be 25 mil. We can constrain it to not go beyond this, but for now let's keep it simple and let's cut it using the paint holder params dot cutout depth. Wow, so I need a 3x2 to create one. That's insane. Wait, give me a second. Okay, I can confirm that this is accurate. Wow. Okay. So now what we need to do is to pattern this. And one thing I learned about patterns, especially lattice pattern, because there is a pattern here in the part design workbench, but I don't like it too much because the way it works is very weird. You just give it a length and then how many items you want to put. But this is not what we want. So if I cancel, I go to lattice workbench, create a new array, and this is already looking good. What we need to do is come down here, go to count, and we're gonna call this paint params dot number. Yeah, X number of bottles is the count. And then the generator mode is gonna be step on. And each step will be, so now we're thinking about the distance between the center of this circle to the center of the other circle. This is important. Why? Because the spacing that we have here is not from the center. It's from the edge to the edge. So when you go from the center to the center, you're going by a radius, then the spacing, then another radius. So it's basically the spacing plus the diameter. I don't know what happened here, but let's just ignore it. So this one is going to be the diameter plus the spacing on the X. And this is the distance between two. Now, previously I used to align, like take this array and then align it in the center. Apparently this is not required. Doesn't matter. I can just, as long as I have the distance correct and the array is facing the right orientation, then I can just do that and it will work. And now, for example, if we go to part design and then can we do circles? Yeah, the distance between the two is 8.5, which is exactly the distance we have here, which is nice. Nice, nice, nice. Now, how do we do 2 on the Y, for example? It's not gonna look good. And that's because we don't have enough space. So if I go back here and we change the Y to 3, now it's gonna look better, but we only have 2. Or we only have 1 row. Where's the other row? We didn't do any array this way, so let's do it. We go to lattice again, create a new array, but this time I'm gonna set the direction to y-axis, and this is a bit tricky because when I set this to 1, it's going to get like a diagonal thing because I need to set the x to 0, and now it's gonna work. So again, the same. We're gonna set this to step, and the count will be number of bottles on the Y, and the step will be the same. So paint bottle params dot diameter plus paint bottle params dot spacing on the Y. Warning, unit discarded. Okay. Units does not matter that much, I guess. So now if we take this and the lattice param, we can the lattice pattern, sorry, we can pattern the pattern to get this grid. Now there are other ways. We could have created 2 arrays, one going this way, one going this way, and then pattern the array instead, and then join the 2 arrays and then do the pattern on the cutout. But it doesn't matter which way you do it, all of it will work. So now we ended up with a 3x3, which is 1 second. I have a 3x6, so we have a 3x3, so I will end up with a 3x3, another 3x3, so we can put 1 2 3 4. We can put 8 bottles of this size, but I don't even have 8 bottles of this size. I only have, yeah, I think I have 4 of this size. So we can create a different one. For example, let's say I want to put a 24 ml or 25 ml bottle. Right, now we can do, let's say 5. Yeah, that's 4. We end up with a 5 ml edge, and I guess 4x4. And now we can put 1 2 3 4 5 6 7 8 9. Why I'm doing that? 16. Oh my god. 4x4 16. Yeah, that's the beauty of parametric design. And let's say I wanna make this smaller, can do that. Cool, what else do we want to do? So I'm gonna stick with the, I think what I will do, because I want to use as less whoops, not 23, no, I want to use as less of these as I can. So let's stick with 2x1. 2x1, maybe on the x, yeah, on the x2, on the y1. I'm looking at it from a wrong angle. And can we make it smaller? Let's see. Y grid units 2. Yeah, 1 grid unit is impossible. I think. Yeah. I mean, this could work. But will it interfere? It will interfere with the others. So I can no longer put anything here. So this has to be 2. So 2 by 3, I can put 2 of these. Now, if I make this 2 by 2, then I can only put 1. But then this is not using this space very efficiently. Because if I want to put another one here, yeah, the most efficient one is going to be what we had, 3 by 3. My only issue with that is I only have 3 of these, I think. I can probably fit something here. How are these even printed? Oh, they are printable. Ah, okay. Now I understand the engineering behind this. This is actually genius. So you can basically print it on these faces. Because this is an overhang. It will print fine. All of these are overhangs. They will print fine. Now this is a bridge. This is genius. I love good design. I mean, design that is made for 3D printing. Because normally if this was not, these edges were not made like that, chamfered, and instead it was like, for example, it was going like this, then like that. Yeah, this edge right here will not be able, you will not be able to print it at all. But this is genius. Anyways, the paint thing is done. Paint bottle thing. Now, if I want to use this like super efficiently, I would put 3 here and then maybe 4 small bottles here. Is it possible though, doing it parametrically? Because if I have an array like this, and then, yeah, no. That's not possible with Excel sheets, at least. At least with my experience, it's not possible. Maybe someone else has more experience and they can do it. I don't know. And I really like this. So I was expecting this to be a long video because I was expecting to model all of these. And then I found this workbench and we did it in like a click or two. That was amazing. I was not anticipating this at all. We'll probably model many things in this Gridfinity thing, especially with this stacking clip. But it will not work for this specific situation. But what I have in mind is like one of the issues I'm facing with lure making is that there are just so many steps. Like, for example, when I print a lure, right? And I want to go assemble it. So to assemble the lure, I want to create twist wire, for example. So I want to create, let's say, 3 twist wires and then 2 interlocking twist wires to glue in a 2-piece or a 3-piece swim bait, for example. And I have to do this for every lure. But what if I have one of these Gridfinity things that are stackable on top of each other and they have labels, and then I can pre-twist, let's say 50 or 100 twist wire with different wire thicknesses, for example, and different diameter of of the eyelet itself. Um, and I stack them in that stand. That would be amazing. That will definitely make my process a lot faster and a lot more efficient. So it's not just about organizing stuff that to look nice. It's also about efficiency and making the lure making process more enjoyable, basically. So for that thing, what I would do, let's say we create another part. Let's call this one. Let's call it the twist wire bin. Whoops. Twist wire bin, for example. And this is just an example. I'm not gonna save it here. We can create a body, make it active. Then let's create something. Okay, so here's the thing with working in different parts, because now I don't have to hide this part and work on this one. I can move the entire part in the placement tab. Let's say position on the X, for example, and I move it this way. So I move the entire part, and then the position or the axis of this body is still in the same place. It did not change. Even if this part had 3 or 4 bodies, it doesn't matter. Okay, cool. I can come here, let's say remove the magnets. Can I keep them? No, let's remove them. Where is it? Magnet holes, false, screw holes, false, stacking lip true. I want the stacking lip. And then maybe, let's see. Yeah, I think 1 is enough for these. So 1 by 1, make it small, something like that. And then I can go back to part design, and I can give it a thickness, make it inwards, and enable intersection. It doesn't work. No, apparently it does not. Huh. Something happened. Okay, thickness does not work, but it's easy to do, because we can, like, come on, do it on this plane. Nope, wrong plane. This plane. We can come here, and it's already in the center, so centered rectangle. Do something like this. Of course, we're gonna round out the corners and then pocket it. Let's say by 30, for example. So now we have this bin. We can, for example, make an indentation here for the labels. These are stackable. So we can take one of these, stack it on top of the other one. And that's where I will put my twist wires. Now, of course, if I'm doing this, I will have a spreadsheet. So here, for example, I will have a spreadsheet, create new one. Let's call it twist wire bin params, and then put it inside the body. Oops, inside the part. Yeah. And then add some params here to define like the thickness and stuff like this. Like, for example, here I think we had something called height, custom height. So we can do this like, say 34. Did it work? Custom height, yeah, 34. I don't, huh. I don't think this one is working. That's weird. Oh, is it this? Base profile height? Total height? No. These are not editable. Okay, that's weird. Ah, okay, that's how you change. Wait, what? So you change them in increments. Increments of what? Total height. Let's set it to 1. It's 7. 2. It's 14. 3. Okay, so it's multiplied by 7. That is weird, but that's how it is. And I guess this is needed for the stackability. Because if you have like a 7 and a 7, then you have 14, and then you can make one that's 14 mil tall, and they will be flush with each other. Oh my god, what's wrong today? So yeah, that was like a very quick episode today. It's a very simple thing that we did. But I'm a bit tired, so I'm not gonna do anything else. Today was my first day at work, and it was a bit overwhelming, so I'm gonna stop it here. Let's see, actually, before I leave, let me just see. So if we export this, and first let's save it. Desktop, free CAD. Let's call this Gridfinity stuff. Create Gridfinity stuff. And now I can pick the paint holder, export, Gridfinity stuff. Let's make Gridfinity 50 mil paint holder 2x2. Where's the music? And now we can see it. So this is PETG, Bambula PETG HF. It's an amazing filament. So with the default setting, it's 3 hours. I would not use grid infill. It messes with the nozzle sometimes. I don't think I need super strength for this, so 10% should be fine. Yeah, so it's almost 3 hours. Yeah, that's what I mean when I said that design of Gridfinity is genius. So look at this. Look at how it's going. It's not even an overhang. It's barely an overhang. And then it reaches a point where it's a bridge. So the gap that the gap that is being bridged is so low or so small that it should print very well. Nice. 160 grams of filament. Wow, that's too much. This is probably too big. Anyways, I think what I can do is reduce the height, and I only need this amount, I guess, just to keep it in place. So I'm gonna mess around with these settings. It's probably gonna be somewhere here though. So something like maybe half, uh let's say here. Yeah, it's gonna be half probably the amount of material used, and maybe even half the time. No, it's not gonna be half the time because the majority of the time is here, I guess. But anyways, that's all for today. Thank you for tuning in. And if you have any questions, just send me a message on Discord and I'll try my best to answer it as soon as possible. So, yeah, have a nice day and see you in the next live stream.